Now we have come to the second part of calculus, which is lesson 15, integration. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Now, let's start the lesson with the concept of integration, which is the area under a graph. Now, let's look at this diagram. We have the x and the y axis, and here is the curve with the equation y equals to fx. Now, if I draw two straight lines and it is bounded by the area under the curve, the question is, what is the area of the shaded region? Now, to find the area of the shaded region, what we need to do is we need to zoom the shaded region very big until we can see that the region is made up of many rectangles with equal width delta x. And here's how it looks like. So we zoom out this area, and this is what we will see. You see the first tiny rectangle with the width of very small x, which is delta x, and the height is y1, followed by second tiny rectangle with the width of delta x, and the height is y2. Next, the third tiny rectangle with the width of delta x, and the height is y3, and continue until the last tiny rectangle with the small width of delta x, and the height is yn. Now, we can find the total area A, which is the y1 delta x plus y2 times delta x plus y3 times delta x until the last tiny rectangle area, which is yn times delta x. From this equation, we can factorize the small change of x, which is the delta x, and it becomes y1 plus y2 plus y3 plus until the last yn multiply with delta x. Or we can summarize this equation to be summative of y times delta x. However, this symbol represents discrete summation. Since the graph is a continuous graph, then we need to rewrite this equation to become integration of y dx. And this is a continuous summation of integration. So it starts with the a and end with the b. So we can write the equation to be integration of a to b y dx. From here, we can make the conclusion that integration is the area under the graph of a curve. Integration of y dx is known as indefinite integral of y. After learning the concept of integration, let's talk about some basic rules of integration and relationship between differentiation and integration. Rule number 1. If y equals fx, then integration of y dx equals integration of fx dx. Example, if y equals to x squared, then integration of y dx equals integration of x squared dx. Rule number 2. If d over dx, capital Fx, equals small letter fx, then integration at small letter fx dx equals capital letter fx plus c. Remember, after integration, there is a constant behind plus c here. Okay, now here's an example, if d over dx x squared equals 2x, then integration of 2x dx equals x squared plus c. Rule number 3. Integration of k fx dx equals k integration of fx dx, where the k is a constant. So example, integration of 3 bracket 2x plus 1 square dx, we can take out the constant to become 3 integration of 2x plus 1 square dx. Number 4. Integration of fx plus minus gx dx equals integration of fx dx plus minus integration of gx dx. So which means that if there are two functions plus or minus inside the integration, we can integrate them separately with two different integration signs. So here is an example. Integration of 2x plus 1 square plus x squared plus 1 cube dx. From here, we have two functions. The first function is this, which is 2x plus 1 square, and the second function is x squared plus 1 cube. So when we want to integrate, we can split them into two different integration, which is integration of 2x plus 1 square dx plus integration of x squared plus 1 cube dx. After understanding the rules of integration, let's talk about the relationship between differentiation and integration, which is also will tell us how we can do integration. So now referring from rule number 2 that we have discussed just now, which is if d over dx capital Fx equals small letter fx, then integration fx dx equals capital Fx plus c. So what it means here is that if we differentiate a certain function and we get another function fx, so now if we integrate the function that we get from the differentiation, we should get back the same function before the differentiation and plus a c, which is a constant. Alright, so it is something like we are doing plus, then we need to do minus. So the process is reverse, or we know how to do multiplication, we can do division, which is also a reverse process. Okay, so now let's look at the integration of algebraic expression. Number 1, if we differentiate ax in terms of x, we will get a, where a is a constant. Then when we do the integration a dx, we should get back the same expression, which is ax, and plus the c, which is a constant. Okay, now can you see how the differentiation and the integration relates? So I differentiate ax, I get an a. Therefore, if I integrate a, I should get back ax and plus a constant c. Alright, so this is the first integration. Number 2, if d over dx ax to the power n equals an times x n minus 1. So still remember how do we do the differentiation, where first we'll bring down the power, which we get an n here, then power minus 1, then we get n minus 1. So now, when we do integration, we reverse the process, where if you want to integrate ax to the power n dx, so what we need to do is ax power plus 1, which becomes n plus 1, then divide by power plus 1, which is n plus 1, followed by plus a constant c behind. So this is the second integration of algebraic expressions. Number 3, if we want to differentiate ax plus b to the power n in terms of dx, so what we need to do is we bring down the power, which we get an n here, Then we copy the function inside the bracket, which is ax plus b, followed by the power minus 1, and then we get n minus 1. And then we differentiate the function inside the bracket. For this case, we get an a. Therefore, now, if we want to integrate ax plus b to the power n dx, so we will need to reverse the process, where first we will copy the function inside the bracket. Now the power plus 1, so we get the n plus 1 here, followed by divide n plus 1 at the bottom, and when we differentiate the bracket, we get an a. The a we also put at the bottom here, so we have this a times n plus 1, and then followed by plus a constant c here. Alright, so this is the third integration of algebraic expression, and for this case, n shouldn't be equals to -1. Now we can start to do some integration of algebraic expressions. Here is the example. Find each of the following indefinite integrals. A. Integration of 4x cubed minus x plus 5 dx. B. Integration of sub x bracket 2 sub x minus 3 over x dx. C. Integration of 5 bracket 1 plus 2x cubed dx. Here is the solution. For A, integration of 4x cubed minus x plus 5 dx. In this expression, there are three terms, which is 4x cubed minus x plus 5. So when we want to integrate, we can integrate them separately. So for the first one, 4x cubed, it becomes 4x power 4 over 4. So how we get this value? Remember, right, when we do integration, the power need to plus 1. So 3 plus 1, we get 4. And then divide by power plus 1, which we get over 4 here. Then move on to the second term, minus x. When you integrate, so power is 1, plus 1, then we get a 2 here. After that, divide by power plus 1, then we have over 2 here. Now we move on to the third term, 5. So it's a constant. When we integrate a constant, we get 5x. So after that, remember to plus a constant c behind for indefinite integrals. Then from here, we can simplify. The answer become x power 4 minus x squared over 2 plus 5x plus c. So this is the answer for A. For B, integration of sub x bracket 2 sub x minus 3 over x dx, we can expand the bracket, which we get 2x minus 3 x to the power of negative 1 over 2. Notice that for a fraction, we should change it into in the indices form so that we can integrate it easily. So from here, we have two terms. The first term is 2x, the second term is negative 3x to the power of negative half. So now, let's integrate one by one. For integration of 2x, so the power is 1, so 1 plus 1, we get power 2 here, x squared. Divide by power plus 1, then we have over 2 here. For the second term, the power is negative half, plus 1, then we get half. Divide by power plus 1, then we have to divide by half here, and then plus a c. From here, we can simplify, and the answer become x squared minus 6x to the power of half plus c. Or put it back into the third form, then we get x squared minus 6 sub x plus c. For C, integration of 5 bracket 1 plus 2x cubed dx. So remember, right, this is a constant. We can actually either we take it out or we just copy it here, 5, and then we just need to integrate 1 plus 2x cubed. So we will copy the bracket, right, the expression inside the bracket. After that, the power plus 1. So 3 plus 1, we get 4. Then divide by the power plus 1, we have the 4 here. And also differentiate the bracket, 1 plus 2x, we get a 2. The 2 we put at the bottom as well. Then we have a 2 here. And plus a c, a constant c. Right? Then after that, we simplify. The expression becomes 5 over 8 bracket 1 plus 2x power 4 plus c. Alright, now you can try this example yourself. Find each of the following indefinite integrals. A. Integration of 5x power 4 minus 2x plus 7 dx. B. Integration of 3 minus 2x cubed plus 5x power 4 over 4x cubed dx. C. Integration of 3x minus 1 times 2x plus 5 dx. D. Integration of x times 2x minus 1 square dx. E. Integration of 2x minus 4 over 2x minus 1 square dx. F. Integration of 2x minus 1 square minus 4 over 2x minus 1 to the power 4 dx. You can pause the video and try to do it yourself. Okay, here is the solution. For A, integration of 5x to the power 4 minus 2x plus 7 dx. So we can integrate separately. Integrate 5x power 4. So power 4 plus 1, we get power 5. And over power plus 1. So over 5. Minus 2x, right? Power 1 plus 1 is square. Then over 2. Integration of constant 7. Then we get 7x. Then followed by plus a c. Okay, after that, simplify. We get x power 5 minus x squared plus 7x plus c. Okay, for B, integration of 3 minus 2x cubed plus 5x4 over 4x cubed dx. So from this case, right, we can see that the denominator, there is only one term here, 4x cubed. So before we want to do integration, we can split them up into 3 different fractions, which becomes integration of 3 over 4x cubed minus 2 cubed over 4x cubed plus 5x power 4 over 4x cubed. After that, simplify and put them into the indices form. We get integration of 3 over 4x to the power of negative 3 minus half plus 5 over 4x. And now we can start to integrate. So for the first expression, the power is negative 3, so plus 1, we get negative 2, and over plus power plus 1, then you get a negative 2 here. Then second term, integration of constant, half, so we get negative half x. The next one, 5 over 4, x, so when we integrate x, so the power plus 1, we get a 2 here, then over 2 here, then plus a c. Okay, so after that, we can simplify this expression, which becomes negative 3 over 8 x squared minus half x plus 5 over 8 x squared plus c. For C, integration of 3x minus 1 times 2x plus 5 dx. So what you can do is, you can expand, which we get integration of 6x squared plus 13x minus 5 dx. Now we can integrate separately. So integration of x squared, we get the x squared, the 2 power plus 1, we get a 3, then over 3 power plus 1, right? Okay, then second term, x power 1 plus 1, we get 2, then over 2. Okay, the constant, we just copy 13, we still have 13 here. The next one, integration of 5, a constant, right? Then we get 5x. So minus 5x plus c. After that, we can simplify this expression, which becomes 2x cubed plus 13 over 2 x squared minus 5x plus c. So this is the answer for C. Next, for D, integration of x bracket 2x minus 1 square dx, we can expand the bracket first, which we get integration of x bracket for x squared minus 4x plus 1 dx. After that, we expand the x into the bracket. So we get 4x cubed minus 4x squared plus x dx. Now we can integrate them separately. So for 4x cubed to the power 3 plus 1, then we get 4. Then over the power plus 1, then over 4 here. The second term, the power is 2 plus 1 becomes 3. Then over power plus 1, which is 3. The next one, integration of x. So power plus 1 become 2. Then over power plus 1, we get a 2 here. Then followed by plus a constant c. After that, we can simplify the expression, which becomes x to the power 4 minus 4 over 3 x cubed plus half x squared plus c. Next, E, integration of 2x minus 4 over 2x minus 1 squared dx. So I believe you should know that you need to change it into indices form first before you want to integrate. So we get integration of 2x minus 4 times 2x minus 1 to the power of negative 2 dx. Now we can integrate separately. So integration of 2x, the power is 1. Then we get power plus 1, 2x squared over 2 power plus 1, which is 2 here. After that, the 4 here, we just copy 4. And then this is 2x minus 1 to the power of negative 2. So power plus 1, we get negative 1. Okay, we copy the function inside the bracket. So followed by the power plus 1, we put at the bottom. So we have the negative 1 here. After that, we differentiate the expression in the bracket. So for this case, we get a 2. So we put it at the bottom, then the 2 here. Alright, then followed by plus a c. After that, we can simplify. We get x squared plus 2 over 2x minus 1 plus c. So this is the answer for E. Next, for F, integration of 2x minus 1 squared minus 4 over 2x minus 1 to the power 4 dx. I hope that you can see that the function inside here, right, there is one term at the denominator. So if there is one term at the denominator, we can split them up into two different fractions, which you get integration of 2x minus 1 squared over 2x minus 1 to the power 4 minus 4 over 2x minus 1 to the power 4 dx. Alright, so can you guess what is the next step? I hope you know, right? The next step, you have to simplify and change them into indices form. So for the first expression or the first term here, right, when you simplify and put it into the indices form, we get 2x minus 1 to the power of negative 2. Similarly, for the second term, so minus 4, right, it becomes minus 4 times 2x minus 1 to the power of negative 4. Right, so now you can integrate them separately. So for the first term, 2x minus 1 to the power of negative 2, so we just copy the function inside the bracket, 2x minus 1, then power minus 1, power plus 1. So negative 2 plus 1, we get negative 1. Right, after that, negative 1 we put at the bottom. We still have a negative 1 here. Then followed by differentiate the bracket. For this case, we get a 2 here. Then we put at the bottom 2. Okay, then the next one, to the second term, right, the 4 constant, we copy the 4 here. Followed by integrate 2x minus 1 to the power negative 4. So the power plus 1, we get negative 3 here. So 2x minus 1 to the power negative 3. Then negative 3 right at the bottom here. Then followed by differentiation of the function inside the bracket. So for this case, we get a 2 and we put at the bottom and plus a c. Okay, so once you get this, the next step is just simplify and put it into the fraction form. Then we get negative 1 over 2 times 2x minus 1 plus 2 over 3 times 2x minus 1 cubed plus c. So this is the answer for F. Do you get all the answers correctly? Now, let's learn the integration of trigonometric expression. We use the exact same rule, which is rule number 2. If d over dx capital Fx equals small letter fx, then integration of small letter fx dx equals capital letter Fx plus c. So, for integration of trigonometric expression, if rule number 1, if d over dx cosine x equals negative sine x, then integration of sine x dx equals, can you guess the answer? Yes, it is negative cosine x plus c. So remember this formula. Now number 2, if d over dx sine x equals cosine x, then integration of cosine x dx, can you guess the answer? Yes, it is equals sine x plus c. So please remember this second equation. Number 3, if d over dx tangent x equals secant square x, now can you tell me what is the answer for integration of secant square x dx? Yes, it is equals tangent x plus c. So remember these 3 equations. Number 4, if d over dx cosine ax plus b equals negative a sine ax plus b. Alright, I hope that you still remember how to differentiate cosine ax plus b. So it's very easy. We need to differentiate cosine, which you get negative sine ax plus b. Then after that, we have to differentiate ax plus b. Then we get an a at the front. Okay, so now can you tell me if I want to integrate sine ax plus b dx, what will be the answer? Okay, so the answer is pretty simple. So we integrate sine, we get negative cosine ax plus b. Followed by, we differentiate ax plus b, then we get a. It will be 1 over ax, 1 over a. Followed by plus c. Alright, so remember this equation. Next, number 5. So similarly, if d over dx is d over dx sine ax plus b equals a cosine ax plus b, then can you tell me integration of cosine ax plus b dx, what will be the answer? Okay, it will be 1 over a sine ax plus b plus c. Right, so it's similar concept. Integrate cosine, I will get sine ax plus b. Then I differentiate ax plus b, I get an a. So it will be 1 over a. Followed by plus c. Okay, so this is the next equation that you need to know. Number 6, if differentiation d over dx tangent ax plus b is equal a secant square ax plus b, right? So is differentiate of tangent, I get secant square ax plus b, then differentiate ax plus b, I get an a. I put it here in front. So how about this? Then integration of secant square ax plus b. So can you tell me the answer? Yes, it will be 1 over a tangent ax plus b plus c. Okay, the concept is very similar. Integration of secant square, we get tangent ax plus b. Then I differentiate ax plus b, I get an a. So I will write 1 over a here, and then followed by plus c. So this is the third equation that you need to know for the function of sine, cosine, and tangent of ax plus b. Alright, so now we already learned how to integrate trigonometric expression. Let's look at the example here. Find each of the following indefinite integrals. A. Integration of cosine 2x minus 5 dx. B. Integration of pi sine pi x plus 3 dx. C. Integration of secant square 6 minus 3x dx. Here is the solution. For A, integration of cosine 2x minus 5. So I think it's pretty straightforward, right? So integration of cosine, I get sine. Therefore, I will get sine 2x minus 5, followed by differentiate of 2x minus 5, I get a 2. So it will be over 2 here, followed by plus c. Or I can rewrite the equation, it becomes half sine 2x minus 5 plus c. For b, integration of pi sine pi x plus 3 dx. So you have to treat the pi as a constant. Okay, so now integration of sine, I get negative cosine pi x plus 3, followed by differentiate of pi x plus 3, I get a pi, so it's over pi here, right? So the pi here we just copy, and then from here we can simplify pi and pi cancel each other. I will get negative cosine pi x plus 3 plus c. So this is the answer for B. For C, integration of second square 6 minus 3x dx. So pretty straightforward. Integration of second square 6 minus 3x, I'll get tangent 6 minus 3x. After that, differentiate 6 minus 3x, I get a negative 3. So it will be over negative 3. Or can rewrite the equation, it becomes negative 1 over 3 tangent 6 minus 3x plus c. Now, you can try this example yourself. Find each of the following indefinite integrals. A. Integration of x minus sine 2x plus 3 dx. B. Integration of 4 second square x over 2 dx. C. Integration of cosine half x minus 3 sine 2x dx. You can pause the video and try to solve it yourself. Here is the solution. For A, integration of x minus sine 2x plus 3 dx, what you can do is you can integrate them separately. This is the first function x and this is the second function minus sine 2x plus 3. So integration of x, you get x squared over 2. Integration of minus sine 2x plus 3 becomes plus cosine 2x plus 3 over 2. Because after integrate the trigo, we can differentiate 2x plus 3, we get 2, and we put the 2 at the bottom here. So it becomes cosine 2x plus 3 over 2. Then the last step, plus a c. This equation, you can rewrite it become half x squared plus half cosine 2x plus 3 plus c. For B, integration of 4 second square x over 2 dx. So we integrate second square, we get tangent. And we differentiate x over 2, we get half. Therefore, it becomes equals 4 tangent x over 2 over half plus c. And we write this equation, it becomes 8 tangent x over 2 plus c. For C, integration of cosine half x minus 3 sine 2x dx. So integration of cosine half x, we get sine half x over half. Integration of negative 3 sine 2x, we get positive 3 cosine 2x over 2 and plus the c. We can rewrite this, it becomes 2 sine half x plus 3 over 2 cosine 2x plus c. This is the answer for C. Now, let's learn how to integrate more complicated trigonometric expressions using formula. We know that cosine 2x equals 1 minus 2 sine square x. From here, we want to make sine square x a subject, so we get 2 sine square x equals 1 minus cosine 2x. Therefore, sine square x equals half minus half cosine 2x. So, number 7, if we want to integrate sine square x dx, it is equal half integration of half minus half cosine 2x dx, which will get half x minus half sine 2x over 2 plus c. And we can simplify it, it becomes half x minus 1 over 4 sine 2x plus c. We also know that cosine 2x equals 2 cosine square x minus 1. Now, we want to make cosine square x the subject. Hence, 2 cosine square x equals cosine 2x plus 1, and cosine square x equals half cosine 2x plus half. Therefore, number 8, integration of cosine square x dx equals integration of half cosine 2x plus half dx. So, the answer will be equals half sine 2x over 2 plus half x plus c. And we can simplify further. It becomes 1 over 4 sine 2x plus half x plus c. This is another formula that we know, which is 1 plus tangent square x equals secant square x. So tangent square x equals secant square x minus 1. Therefore, number 9, if you want to integrate tangent square x dx, it is equal integration of secant square x minus 1 dx, which is tangent x minus x plus c. So this slide shows you how to integrate the trigonometric expressions with a square. Now, let's look at this example. Find each of the following indefinite integrals. A. Integration of 3 tangent square 2x dx. B. Integration of sine 2x cosine 2x dx. C. Integration of 2 sine square x over 2 dx. And D. Integration of 4 cosine square 3x dx. Here is the solution. For A, integration of 3 tangent square 2x dx. Recall that 1 plus tangent square x equals secant square x. Therefore, tangent square 2x is secant square 2x minus 1. So now from here, we want to integrate 3 integration of secant square 2x minus 1 dx. And it becomes 3 bracket tangent 2x over 2 minus x plus c. When you expand the 3 inside, we get 3 over 2 tangent 2x minus 3x plus c. For B, integration of sine 2x cosine 2x dx. Notice that there is a multiplication of sine and cosine with the same angle 2x and 2x. From here, we can apply the formula, which is sine 2x equals 2 sine x cosine x. So, from this formula, if this is x, this is 2x. And what we have is 2x, then we can get equals half integration of 2 sine 2x cosine 2x dx, which becomes half integration of sine 4x dx. So from here, when we integrate sine 4x, we get negative cosine 4x over 4, and this expression, when we simplify it, we get negative 1 over 8 cosine 4x plus c. For C, integration of 2 sine square x over 2 dx. So remember that sine square x equals half minus half cosine 2x. Therefore, integration of 2 sine square x over 2 dx becomes 2 integration of half minus half cosine x dx. And we get integration of 1 minus cosine x dx by just multiplying the 2 inside. Then we can eliminate the half. So from here, we can start to integrate. 1 becomes x. Integration of negative cosine x becomes minus sine x plus c. For D, integration of 4 cosine square 3x dx. Recall that we use this formula, cosine square x equals half cosine 2x plus half. So this expression becomes 4 integration of half cosine 6x plus half dx. And we can multiply the 4 inside. So 4 times half we get 2. then it becomes integration of 2 cosine 6x plus 2 dx. And we can start to integrate, which becomes 2 times sine 6x over 6 plus 2x plus c. And simplify, we get 1 over 3 sine 6x plus 2x plus c. Alright, now you can try this example yourself. Find each of the following indefinite integrals. A. Integration of 4 tangent square 3x dx. B. Integration of sine 2x plus 1 cosine 2x plus 1 dx. C. Integration of 3 cosine square x over 3 dx. And D. Integration of 2 cosine cube x plus pi minus 3 over cosine square x plus pi dx. You can pause the video and try to solve it yourself. Okay, here's the solution. For A, integration of 4 tangent square 3x dx. Recall that we can use this formula. 1 plus tangent square x equals secant square x. So tangent square 3x is secant square 3x minus 1. So it becomes 4 integration of secant square 3x minus 1 dx. So which will get tangent 4 tangent 3x over 3 minus x plus c. Simplify, we get 4 over 3 tangent 3x minus 4x plus c. For B, integration of sine 2x plus 1 cosine 2x plus 1 dx. Recall that we can use this formula. Sine 2x equals 2 sine x cosine x. So we have to modify this expression, which becomes half integration of 2 sine 2x plus 1 cosine 2x plus 1 dx, and it becomes half integration of sine 2x plus 1 dx. Then we multiply the 2 inside the bracket so that later on we can integrate easily, which becomes half sine 4x plus 2 dx. And now we can start to integrate, which becomes negative half cosine 4x plus 2 over 4 plus c. And we simplify it. The answer is negative 108 cosine 2 bracket 2x plus 1 plus c. For C, integration of 3 cosine square x over 2 dx. So recall that we can use this formula. Cosine square x equals half cosine 2x plus half. So the integration becomes 3 integration of half cosine x plus half dx. And we can integrate one by one, which becomes 3 times half sine x plus half x plus c. Then we multiply the 3 into the bracket, or we factorize the half. We get 3 over 2 sine x plus c. For D, notice that there is only one term in the denominator. So we can break this expression into 2 fractions, which becomes integration of 2 cosine cube x plus pi over cosine square x plus pi minus 3 over cosine square x plus pi dx. So we simplify it, becomes integration of 2 cosine x plus pi minus 3 secant square x plus pi dx. And now we can integrate, which will become 2 sine x plus pi minus 3 tangent x plus pi plus c. So this is the answer for D. Now, let's learn the integration of 1 over x, 1 over ax plus b, and more generally, f prime x over fx. We will use the same rule, which is rule number 2. If d over dx, capital Fx, equals small letter fx, then integration of small letter fx dx equals capital letter fx plus c. Hence, let's look at the integration of 1 over x, 1 over ax plus b, and f prime x over fx. Number 1. If d over dx ln x equals 1 over x, then integration of 1 over x dx will be equals ln x plus c. So please remember this equation. Number 2, if d over dx ln bracket ax plus b equals a over ax plus b, then integration of a over ax plus b dx equals ln ax plus b plus c. Please remember this equation. Number 3, if more generally d over dx ln fx equals f prime x over fx, then integration of f prime x over fx dx equals ln fx plus c. Please remember this equation. Now, let's look at this example. Find each of the following indefinite integrals. A. Integration of 3 over 2x minus 5 dx, and b. Integration of 6x minus 4x squared over 3x squared dx. So, here's the solution. For A, integration of 3 over 2x minus 5 dx. So, firstly, how do I know that I need to use this technique? So, firstly, you have to check the expression inside the integration, it is a fraction. Alright? So, now, I can rewrite this integration which becomes 3 over 2 integration of 2 over 2x minus 5 dx. Why is it so? Because do take note that if I differentiate 2x minus 5, it is equals to 2. So, the numerator of the fraction should be 2. Okay, and the original expression should have no 2 here. So, I have to put a divide by 2 here. And now, I check that the expression inside the integration is in the form of f prime x over fx. So, I can immediately say that it is equal 3 over 2 ln 2x minus 5 plus c. So for b, integration of 6x minus 4x squared over 3x squared dx. I hope that you can see that the denominator has only one term. So we can split this fraction into two different fractions, which equals integration of 6x over 3x squared minus 4x squared over 3x squared dx. When you simplify it, you get integration of 2 over x minus 4 over 3 dx. Notice that this 2 over x, it is equals 2 times 1 over x. Therefore, when I integrate 2 over x, it becomes 2 ln x. When I integrate negative 4 over 3, it becomes negative 4 over 3x, then plus a c. So this is the answer for B. Now, you can try this example yourself. Find each of the following indefinite integrals. A. Integration of 2x cubed plus x squared minus 3x plus 1 over x squared dx. B. Integration of 2x minus 3 squared plus 5 over 2x minus 3 dx. C. Integration of tangent x dx. You can pause the video and try to solve it yourself. Here is the solution. For A, integration of 2x cubed plus x squared minus 3x plus 1 over x squared dx. Again, notice that the denominator has only one term. So, you can split these fractions into a few fractions, which becomes integration of 2x cubed over x squared plus x squared over x squared minus 3x over x squared plus 1 over x squared dx. Then, you can simplify and change them into indices form where necessary. For example, 1 over x squared which becomes x to the power of negative 2. Now, we can integrate one by one. So 2x becomes 2x squared over 2, 1 becomes x. Integration of negative 3 over x becomes negative 3 ln x. And integration of x to the power of negative 2, so power plus 1, then we get negative 1 over power plus 1, then over negative 1 plus c. Then we can simplify and put it back into the fraction form where necessary. So it becomes x squared plus x minus 3 ln x minus 1 over x plus c. For b, integration of 2x minus 3 squared plus 5 over 2x minus 3. So notice that in the numerator, there is a term where it is 2x minus 3. The denominator also is 2x minus 3. So you can break this fraction into 2, which becomes integration of 2x minus 3 squared over 2x minus 3 plus 5 over 2x minus 3 dx. So simplify it becomes 2x minus 3 for the first term. And for the second term, we want to put the fraction into the form of f prime x over fx. Therefore, the constant, we put it outside. And at the top, we need to differentiate 2x minus 3, we get 2. Hence, there's a 2 here. And we need to put over 2 here. Alright, so now it is in the form of f prime x over fx. And we can start to integrate one by one. 2x becomes x squared, minus 3 becomes negative 3x. And integration of 5 over 2 times 2 over 2x minus 3 becomes 5 over 2 ln 2x minus 3 plus c. Alright, for c, integration of tangent x dx. Remember that previously we have learned integration of sine x dx, integration of cosine x dx, and integration of secant square dx. But we don't learn integration of tangent x dx. Now, how are we going to integrate tangent x dx? We can change tangent x dx into integration of sine x over cosine x dx. Recall that differentiation of cosine x equals negative sine x. Hence, we can rewrite the expression which becomes negative integration of negative sine x over cosine x dx, so that it is in the form of f prime x over fx. Now, we can say that it is equals negative ln cosine x plus c. Notice that we have modulus sign here because we know that cosine x can be largest value is positive 1 and smallest value is negative 1. But the body inside the ln shouldn't be a negative value. So we have to put a modulus sign. Now, let's learn integration of exponential expressions. We still use the same rule, which is rule number 2. If d over dx, capital Fx equals small letter fx, then integration of small letter fx dx equals capital letter fx plus c. So, let's look at integration of exponential expressions. Number 1. If d over dx e to the power of x equals e to the power of x, then can you tell what is the integration of e to the power of x dx? Yes, the answer is e to the power of x plus c. Please remember this equation. Number 2. If d over dx e to the power of ax plus b equals a to the power of ax plus b, then can you tell what is the integration of e to the power of ax plus b dx? Yes, the answer is 1 over a e to the power of ax plus b plus c. Please remember this equation. Number 3, if d over dx e to the power of fx equals f prime x e to the power of fx, then can you tell what is the integration of f prime x e to the power of fx dx? Yes, it will be e to the power of fx plus c. Please remember this equation as well. Now, let's look at this example. Find each of the following indefinite integrals. A. Integration of 2e to the power of 4x minus 3 dx. B. Integration of e to the power of 2x minus 1 plus 2 over e to the power of x dx. Here is the solution. So A. Integration of 2e to the power of 4x minus 3 dx. So what you can do is you just copy exactly the same expression 2e to the power of 4x minus 3 over here. Then you differentiate the power 4x minus 3, which you get 4, and you write the answer at the bottom over 4 then plus a c. Next, simplify, it becomes half e to the power of 4x minus 3 plus c. So this is the answer for A. For B, integration of e to the power of 2x minus 1 plus 2 over e to the power of x dx. I hope that you can notice that the denominator has only one term, so you can break this fraction into two different fractions, which you get integration of e to the power of 2x minus 1 over e to the power of x plus 2 over e to the power of x dx. Then simplify. For the first fraction, since they have the same body, e, then the power, we get 2x minus 1 minus x, which you get e to the power of x minus 1. For second fraction, you can change it into indices form, which becomes 2e to the power of negative x. So the whole expression becomes integration of e to the power of x minus 1 plus 2e to the power of negative x dx. Now we can integrate them separately. So e to the power of x minus 1, we still get the same, which is e to the power of x minus 1. The integration of 2e to the power of negative x, we just copy exactly the same, 2e to the power of negative x. Then we differentiate negative x, we get negative 1. We write it at the bottom, so it's over negative 1 plus c. Then simplify, we get e to the power of x minus 1 minus 2 over e to the power of x plus c. So this is the answer for B. Now, you can try this example yourself. Find each of the following indefinite integrals. A. Integration of 18e to the power of 2 minus 9x plus e squared dx. B. Integration of 4 minus e to the power of 4x over e to the power of 2x dx. You can pause the video and try to solve it yourself. Here is the solution. Integration of 18e to the power of 2 minus 9x plus e squared dx. Okay, one thing you need to take note is that don't be too excited when you look at this e squared. This is a constant. It is not an exponential function. So, integrate them separately. We'll copy 18e to the power of 2 minus 9x. Then put it at the top. We get 18e to the power of 2x, 2 minus 9x. Then we differentiate 2 minus 9x, we get negative 9. We put it at the bottom, so it's over negative 9. And as I said just now, e squared is a constant, so we integrate a constant, it becomes e squared x and plus a c. The next step, simplify, we get negative 2e to the power of 2 minus 9x plus e squared x plus c. For B, integration of 4 minus e to the power of 4x over e to the power 2x. So again, in the denominator, there is only one fraction, only one term. So we can split this fraction into two different fraction, which is integration of 4 over e to the power 2x minus e to the power 4x over e to the power 2x dx. Then you can simplify and put it into indices form where necessary. So we get integration of 4e to the power negative 2x minus e to the power 2x dx. And now we can integrate them separately. So the constant just leave one side, and we just copy e to the power of negative 2x here. After that, differentiate the power negative 2x, we get negative 2. So it is over 2 over negative 2. Then minus the second, e to the power 2x becomes e to the power 2x, and then differentiate 2x, we get 2, so it's over 2 plus c. Then simplify, we get negative 2 e to the power negative 2x minus half e to the power 2x plus c. Do you still remember partial fractions? Well, sometimes integration involves partial fractions as well. The idea of involving partial fraction in integration is that sometimes we need to break one difficult to integrate fractions into partial fractions so that we can integrate it easily. Now, let's look at this example. Find each of the following indefinite integrals. A. Integration of x plus 11 over x minus 3 times x plus 4 dx. B. Integration of 3 minus 2x over 1 minus 2x squared dx. Here is the solution. For A, integration of x plus 11 over x minus 3 times x plus 4 dx. As I mentioned just now, this fraction is difficult to integrate directly. Even if we expand the denominator, we still can't see an easy way to integrate it. Therefore, we have to change this fraction into partial fraction. Hence, it becomes integration of a over x minus 3 plus b over x plus 4 dx. And now, we want to find the value of a and b. So, we do all the steps in partial fractions, which is x plus 11 equals a times x plus 4 plus b times x minus 3. And now, we can say that a plus b equals to 1, and 4a minus 3b equals 11. So this is the first equation, and this is the second equation. We multiply 3 for both sides in equation 1, which gives us 3a plus 3b equals 3. And we label this as equation number 3. And now, we can say that equation 2 plus equation 3, which gives us 7a equals 14. And the unknown b is eliminated. So, a equals to 2. Then, we can say that 2 plus b equals to 1 from the first equation. Therefore, b will be equals negative 1. Hence, we can rewrite the integration, which becomes integration of 2 over x minus 3 minus 1 over x plus 4 dx. And we can integrate them separately, which gives us 2 ln x minus 3 minus ln x plus 4 plus c. Similarly, for b, integration of 3 minus 2x over 1 minus 2x squared dx. Again, this fraction is difficult to integrate directly, even if we expand the bottom 1 minus 2x squared. So, we have to change it into partial fractions, which becomes integration of a over 1 minus 2x plus b over 1 minus 2x squared dx. And next step is similar, which we want to find the unknowns a and b. So, we can write it as 3 minus 2x equals a times 1 minus 2x plus b. From here, we compare the coefficient of the x, which gives us negative 2a equals negative 2. Hence, a is 1. Now we compare the constants. A plus b equals 3, where a is 1. Therefore, 1 plus b equals 3, and b equals 2. Therefore, we can rewrite the integration, which becomes integration of 1 over 1 minus 2x plus 2 over 1 minus 2x squared dx. Alright, so we can put this fraction into indices form before we integrate, which gives us integration of 1 over 1 minus 2x plus 2 1 minus 2x to the power of negative 2 dx. And it is ln 1 minus 2x over negative 2 plus 2 1 minus 2x to the power of negative 1 over negative 1 times negative 2 plus c. And rewrite and simplify, we get negative half ln 1 minus 2x plus 1 over 1 minus 2x plus c. Okay, now you can try this example yourself. Express 3 times x minus 1 over x plus 1 times 2x minus 1 as partial fractions. Hence, find integration of x minus 1 over x plus 1 times 2x minus 1 dx. You can pause the video and try to do it yourself. Here is the solution. So we can write the fraction into partial fraction, which looks like 3 times x minus 1 over x plus 1 times 2x minus 1 equals a over x plus 1 plus b over 2x minus 1. Then we can compare the numerator, which 3 times x minus 1 equals a times 2x minus 1 plus b times x plus 1. And then when x goes to negative 1, we get negative 3a equals negative 6 and a equals to 2. When x equals to 0, negative 3 equals negative 2 plus b, which will get b equals negative 1. Therefore, the partial fraction for 3 times x minus 1 over x plus 1 times 2x minus 1 is 2 over x plus 1 minus 1 over 2x minus 1. Therefore, if you want to integrate x minus 1 over x plus 1 times 2x minus 1 dx, it is equals 1 over 3 integration of 3 times x minus 1 over x plus 1 times 2x minus 1 dx. Why do we want to do this? Because we want to rearrange the equation so that this expression will look like the original expression that we have changed it into partial fraction, so that when we want to integrate, we can just integrate this as 1 over 3 integration of 2 over x plus 1 minus 1 over 2x minus 1 dx, which will give us 1 over 3 bracket 2 ln x plus 1 minus 1 over 2 ln 2x minus 1 plus c. Then expand the bracket, we get 2 over 3 ln x plus 1 minus 1 over 6 ln 2x minus 1 plus c. This is the answer for this example. Now we have learned all the important integration techniques. So it's time for us to look at some applications. The first one is finding the equation of a curve. Here is the example. Find each of a curve which passes through the point 1, 3 and has a gradient function of dy over dx equals 2x minus 3 sub x over x. Here is the solution. So we want to find the equation of the curve, which is y equals the integration of the gradient function, which is 2x minus 3 third x over x dx. And again, notice that there's only one term at the denominator, so we can break it into two different terms, which we get integration of 2 minus 3x to the power of negative half dx. Then we can integrate them separately. Integration of 2, we get 2x. Integration of 3x to the power of negative half dx, we get minus 3x to the power of half over half plus c. Then rearrange, we can get y equals to 2x minus 6 x to the power of half plus c, or y equals to 2x minus 6 square root of x plus c. This is the equation of the curve. Now, what we want to do next is to find the value of c. So it is given that the coordinates of a point is 1, 3. So it means that x equals to 1, y equals to 3. Substitute these two values into the equation, we get 3 equals 2 minus 6 third 1 plus c, and c equals 3 minus 2 plus 6, we get c equal to 7. So we can rewrite the equation, which becomes y equals 2 minus 6, y equals 2x minus 6 third x plus 7. Now, let's try this example yourself. A curve y equals fx is such that its gradient function is given by f prime x equals negative 2 times 3x plus a cubed. Given that negative 1, 4 is a stationary point, a. Find the value of a. b. Determine the nature of the stationary point. c. Find the equation of the curve. You can pause the video and try to solve it yourself. Here is the solution. For a, given that negative 1, 4 is a stationary point, which means f prime negative 1 equals 0. So we can substitute x equals negative 1 into f prime x, which will give us negative 2 times 3 bracket negative 1 plus a cubed equals to 0. And we solve this equation. We get a equals to 3. For b, to determine the nature of the stationary point, from the given f prime x equals negative 2, 3x plus 3 cubed, we can get the second derivative, f double prime x equals negative 2 times 3 times 3x plus 3 square times another 3, which gives us negative 18 times 3x plus 3 square. So we substitute x equals to negative 1 into this f double prime x. We get negative 18 times 3 times negative 1 plus 3 square. We get a negative value. Hence, it is a maximum point. Remember, we don't have to really find f double prime x negative 1. We just need to know the sign. C. Find the equation of the curve. To find the equation of the curve, so we need to integrate the gradient function. Therefore, y equals to integration of negative 2 times 3x plus 3 cubed dx. So which will get us y equals to negative 2 times 3x plus 3 to the power 4 over 3 times 4 plus c. Simplify, we get y equals negative 3x plus 3 to the power 4 over 6 plus c. Given that the point negative 1, 4, which means x equals to negative 1, y equals to 4. So we substitute in the equation, 4 equals to negative 3 plus 3 to the power 4 over 6 plus c. Hence, c equals to 4. Therefore, the equation of the curve is y equals negative 1 over 6 times 3x plus 3 to the power 4 plus 4. or y equals negative 81 over 6 times x plus 1 to the power 4 plus 4, which means we actually factorize the common factor 3 here, and it becomes 81. So when you simplify, it becomes y equals negative 27 over 2 times x plus 1 to the power 4 plus 4. Sometimes we may encounter a situation where when we want to integrate a complicated fraction, it is not possible to convert it into partial fraction first before integration. Hence, we have the integration as a reverse process of differentiation. Now, let's look at this example so that you can see the picture clearer. If y equals x squared, square of x plus 2, show that dy over dx equals x bracket 5x plus 8 over 2 square root of x plus 2. Hence, find integration of 5x squared plus 8x over square root of x plus 2 dx. So, this is what I mean here, right? If we differentiate y, we get dy over dx, which is this. So, when we want to integrate this, it is difficult to integrate directly, but with the understanding of rule number 2, if we differentiate this expression, we get this expression. Hence, when we want to integrate this expression, we should get back this expression. Now let's look at the solution for this example. From the given equation, y equals to x squared square root of x plus 2. So we change it into the indices form first, which is x squared times x plus 2 to the power of half. After that, we apply product rule to find dy over dx, which we get 2x times x plus 2 to the power of half plus x squared times half x plus 2 to the power of negative half times 1. Simplify, we get 2x times x plus 2 to the power of half plus x squared over 2 times x plus 2 to the power of half. Combine them together, we get 4x times x plus 2 plus x squared over 2 times x plus 2 to the power of half. Expand the bracket, we get 4x squared plus 8x plus x squared over 2 square root of x plus 2. Simplify, we get 5x squared plus 8x over 2 square root of x plus 2. Then we factorize the x, we get x times 5x plus 8 over 2 square root of x plus 2. So we have proven that the answer that we want to prove, hence shown. Now, let's look at the integration that we want to integrate. So integrate 5x squared plus 8x over square root of x plus 2 dx. Of course, as I mentioned, if you want to integrate directly, it is very difficult to integrate. Hence, we have to modify this expression so that it is the same as the result of the differentiation of the y equation. Hence, it will be equals to integration of 5x squared plus 8x over 2 square root of x plus 2 dx. Because over here, we don't have the 2, so we need to put a 2 at the bottom. And since originally there is no 2 at the denominator, we have to put a 2 at the front. Okay, and now let's double check the expression in the integration. It is exactly the same as the result of the differentiation of the y equation. Hence, we don't have to do anything for this integration. We can just say that it is equal to 2 times x squared square root of 2x plus 2 plus c, which is the equation of the y. Now, you can try this example yourself. Given that d over dx ln 3x plus 2 square equals k over 3x plus 2, find the value of k. Hence, find integration of 2 minus 4 over 3x plus 2 dx. You can pause the video and try to solve it yourself. Here is the solution. From ln 3x plus 2 square, we can bring down the power 2, which becomes 2 ln 3x plus 2. Hence, d over dx ln 3x plus 2 square equals 2 d over dx ln 3x plus 2. And now we can start to differentiate ln 3x plus 2, which gives us 2 times 3 over 3x plus 2. And now we can expand the bracket, which gives us 6 over 3x plus 2. So compare this answer with the answer given. We can say that k equals 6. Next, let's look at the integration. Integration of 2 minus 4 over 3x plus 2 dx. So we can integrate them separately, which we get integration of 2 dx minus integration of 4 over 3x plus 2 dx. So integration of 2 dx, we get 2x. Integration of 4 over 3x plus 2 dx, we can rewrite it becomes minus 4 over 6. Integration of 6 over 3x plus 2 dx. And we don't have to do anything. For integration of 6 over 3x plus 2 dx, it will just go back to the original expression, which is ln 3x plus 2 square. And 4 over 6, simplify, we get 2 over 3. So the whole expression becomes 2x minus 2 over 3 ln 3x plus 2 square plus c. Now, let's look at the integration as a reverse process of differentiation, which involves multiple functions. Here's an example. Differentiate ln x over x with respect to x. Hence, find integration of ln x over x squared dx. Here is the solution. First, we differentiate ln x over x in terms of x, which we need to apply the quotient rule. And this is what we get. X times 1 over x minus ln x times 1 over x squared. We simplify it, we get 1 minus ln x over x squared. Alright, now let's look at the integration part. If you want to integrate directly for integration of ln x over x squared dx, it is difficult to integrate directly, or even we can't see any way we can convert it into partial fraction. So we have to rewrite our equation, which is 1 minus ln x over x squared equals d over dx ln x over x. Then we integrate both sides, which is integration of 1 minus ln x over x squared dx equals ln x over x plus c. Remember, this is the law number 2 or rule number 2, right? If we differentiate this function, we get this function. Therefore, when we integrate this function, it will give us back to this function and plus a c. Okay, so now notice that this is the part that we want, integration of ln x over x squared. So look at this equation. This is the part that we want. So the next step, what we need to do is we want to make integration of ln x over x squared dx the subject. So what we can do is we break this into two fractions, which we get integration of 1 over x squared minus ln x over x squared dx equals ln x over x plus c. Then we integrate this part separately, which is integration of x to the power of negative 2 dx minus integration of ln x over x squared dx equals ln x over x plus c. So now make integration of ln x over x squared dx the subject. We get integration of x to the power of negative 2 dx minus ln x over x plus c. Of course, you can say minus c, but since this is a constant, we just put it in general term as plus c. So now the next step is we just need to integrate x to the power of negative 2, which get us x to the power of negative 1 over negative 1 minus ln x over x plus c. Simplify, we get negative 1 over x minus ln x over x plus c. Alright, so now you can try this example yourself. A. Differentiate 3x ln x with respect to x. Hence, find integration of ln x dx. B. Differentiate tangent cube x with respect to x. Express the derivative in terms of secant square x. Hence, find integration of secant to the power 4x dx. You can pause the video and try to solve it yourself. Here is the solution. First, for A, d over dx 3x ln x, we can use the product rule, which gives us 3x times 1 over x plus ln x times 3. Simplify, we get 3 plus 3 ln x. Now, we want to integrate ln x dx. So, we get back the result that we have 3 plus 3 ln x equals d over dx 3x ln x. Then we integrate both sides. So if we integrate 3 plus 3 ln x dx, we should get 3x ln x plus c. After that, we split these two terms out and integrate them separately. We get integration of 3 dx plus integration of 3 ln x dx equals 3x ln x plus c. Now we want to make integration of ln x dx the subject. Therefore, 3 integration of ln x dx equals 3x ln x minus integration of 3 dx plus c, which we have 3x ln x minus 3x plus c. Next step, everything divided by 3, we get integration of ln x dx equals x ln x minus x plus c. For B, let's differentiate tangent cube x in terms of x, which gives us 3 tangent square x secant square x, or 3 secant square x minus 1 times secant square x. Remember that the question requires us to express the derivative in terms of secant square x. So the answer must be in secant square x. Then we can expand the bracket. We get 3 secant to the power 4x minus 3 secant square x. Now we can do the integration by rewriting the result of the differentiation, which is 3 secant to the power 4x minus 3 secant square x equals d over dx tangent cube x. So if we integrate, so for this case, we divide 3 for both sides. We get secant to the power 4x minus secant square x equals 1 over 3 d over dx tangent cube x. Then we integrate secant to the power 4x dx minus secant square x dx equals 1 over 3 tangent cube x plus c. Hence, make integration of secant to the power 4x dx the subject. We get 1 over 3 tangent cube x plus tangent x plus c. Do you get the answer correctly? Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.